This is the 13th in a series of videos in which I'm attempting to repair this Wren executive computer system. Just to recap on what I've done so far, I've found various failed components. I've replaced the DRAM chips, video RAM chips, and I've had various issues with several buffers that I've replaced, a few glue logic chips. And so I finally got it to the point where I got the welcome screen appearing on the display, and I got various other things working. I got the self-tests to complete, so it's going through all the self-tests and we're getting a steady light on the keyboard, but then it's not going any further. It's just showing the welcome screen and continuously asking for the system disk. So I'll boot it up and you can see what it's doing. Hopefully you can see the floppy drive motors, or at least the one that drives the disk round. So I'll boot up the Wren and you'll see how far it gets. So it's powered on, it's now going through the self-test, and it's finished the self-test, but you can see it's making no attempt to read the floppy drive. And if I look at the interrupt pin on the Z80, so you can see on the scope that line is permanently low. And the reason that the interrupt is permanently low is because the output of the floppy drive controller is permanently high, and that goes through a buffer, through a priority encoder, and then onto the interrupt. And if you recall, I looked at the code using a logic analyzer, and this was causing it to just go around a continuous software loop where it wasn't going any further. So none of the keys worked. It turned out that the keyboard controller chip was faulty, so I replaced that. However, that didn't cure the problem with the keyboard, and that's simply because we're never getting as far as the Wren trying to read any actual characters from the keyboard controller. So as I said, it's booted up. I'll just move the camera so you can see the welcome screen, and this is as far as it ever gets. If I try pressing the reset button on the Wren, it will in fact reset, and then we get this screen. But again, that's as far as it goes, and no amount of key pressing will change this. Now I can force a floppy drive read failure if I lift the interrupt pin on the floppy drive controller and force a release of the interrupt, and then I get a message just saying it's a read failure. And all these things combined tend to lead me to suspect that it is a failed floppy drive controller. So I'll swap that chip out and see if the machine gets any further through its boot up sequence. Okay, so I've swapped the floppy drive controller chip. I've got a new chip in there now. I'll try booting up the Wren and see if we get any further. So it's going through its self-test. And that's a promising sign. It's now trying to read from the floppy disk itself. Okay, but it hasn't booted. I'm still getting the same welcome screen. I'll just move the camera across so you can see what's on the display. I'll try resetting the Wren. The drive is going again. Okay, that's quite a promising sign. We're now getting a disk A read error failure, and we weren't getting that before. And as I said, this tends to appear once the interrupt has been released. So I'll try putting a scope probe onto the interrupt pin on the Z80, and that is indeed toggling, so there's now activity on the interrupt line, which is what we would expect. And if I now look at the interrupt pin coming out of the floppy drive controller, that is now low, which again is what I would expect. It's supposed to go low once it's completed the current action. What should now happen is, if we press a key, we should get the machine to try reading the disk again, but we should also get the character that we press shown on the screen. So I'll press the Y key, and the disk has started spinning again, and also we got the character that I pressed on the keyboard appearing on the screen, and again it's gone back with the same message saying that it's a read error. I'll try it one more time. I'll press a different key this time. I press the T key, and that is in fact what's appearing. So now we know that not only does it seem to be trying to read the floppy drive, but it's also now responding correctly to the keyboard. So that's two major improvements in its performance. So we've got the interrupt working the way it should, we've got the keyboard working the way it should. Unfortunately it's still not booting, so the next thing to do is look to see if we're getting any actual data out of the floppy drive. Okay, so we'll look at the raw data input pin to the floppy drive controller. This is the raw data coming from the floppy drive itself. As you can see on the scope, there is something there now. I don't think that should actually be there at the moment, but I'll try pressing a key and see if we get any activity on that line. And as you can see, we are getting something that looks like actual data. So it could just be noise that's there in the absence of actual data. So if we're getting data going into the floppy drive controller, we'll see if we're actually getting the chip selected. And indeed we are. That's been selected by the Z80 on a regular basis, so it's looking like the Z80 is trying to access that particular chip. We'll look to see if it's trying to read it. And that's a bit indeterminate. This is just a general control line, so we'll need to look at this line in conjunction with the chip select line. We'll also look at the data line to make sure that we don't have a buffer issue. Okay, well, we're not really getting anything in particular on the data bus, so it doesn't appear that the floppy drive controller is actually outputting any data. The floppy drive controller might not realize it's actually read data, so it could be that the format of the data is incorrect, or just simply there's something wrong with the data level or the timing, or there's some corruption somewhere. So I'll start digging around the floppy drive controller, see if I can figure out what's going on. But it is a big step forward. We are now at least seeing some activity on the floppy drive itself. It also looks like data is coming out of the floppy drive. I just need to try and figure out why it's not being propagated by the floppy drive controller. So I've been having to dig around and trying to investigate why the floppy drive is still not being read successfully, even though we seem to be able to drive it and we can see a data stream from it. The floppy drive controller chip controls most aspects of the interface between the host machine and the floppy drive. It is of course possible the floppy drive itself is not working, but that does seem a bit unlikely considering the fact that we can access it, we can see data from it, and we can control the stepper motor and the main drive motor. I've had a look at the two drives and I have swapped them over, and I get exactly the same thing with both of them. But then coming back to the floppy drive controller, we can see the raw data coming into it, but the data ready pin, which is this pin, if we look at the scope, if I re-trigger the drive, so the drive is now spinning, this line is supposed to go high every time the buffer, the read buffer inside the floppy drive controller has valid data. So in other words, the floppy drive controller is never capturing valid data. There is data going into the raw data pin, but that's never being successfully read by the floppy drive controller chip. So if we go back to look at the incoming raw data, that's this line, we can see there is noise on here. Now normally this level of noise on the output of the floppy drive isn't a problem. It is a dynamic circuit that is used in the head read circuit, and the noise that you can see here is normally just mains noise or interference, and it normally is swamped out by the read signals once the disc starts spinning. But just to check, I'll adjust that and make sure that we don't have a noise issue and that the data coming out of the floppy drive can be successfully read. So I'll just adjust the camera so you can see the scope a bit more clearly while I do this. So to adjust the head sensitivity on the drive, what we do is we monitor the raw data coming out of the drive, and then there's a pot on the drive itself. It varies from drive to drive, but the basics of how you do this are always the same. And normally you accept a little bit of noise. As I said, this gives you maximum sensitivity and the circuit will correct this once the disc starts spinning. But what you can do is adjust this pot, and as I turn it you can see the amount of noise coming out of the drive disappears, and you can turn it so you're just not getting any noise at all. If you turn it back the other way, you'll see you get an increasing amount of noise. So this is effectively setting the threshold for the detector circuit on the drive. So I'll turn this till I get no noise at all, so just beyond the threshold where there's any noise showing, and now if I re-trigger the drive, you can see that there's no signal output unless the disc is spinning. So it's probably a little bit insensitive in that position, but I'll leave it there and see if we get any valid data coming out. There's nothing showing so far. I'll go back to the data ready pin on the floppy drive controller and I'll re-trigger the drive, and again still nothing coming out. So what we'll do now is we'll try adjusting the threshold for the floppy drive controller chip. So again, I'll move the camera back so you can see this. Okay, so on the board we have this pot, and this sets the threshold for the data slicer within the floppy drive controller chip. So this pot is used to adjust the input to a pin on the floppy drive controller that is used internally in the data slicer within the floppy drive controller chip to determine what is a short pulse or long pulse in the raw data stream coming from the floppy drive itself. So in other words, this setting allows the floppy drive controller chip to effectively unscramble the data coming from the floppy drive itself and turn it into the correct digital data stream. So that should be pin 18, and we should have a DC voltage on here. And looking at the scope, you can see it's just ground all the time, so that could well be what's causing the problem. This pot is just wired between 0 volt and plus 5 volts, so we should be getting a varying DC voltage on this that sets the threshold going into the floppy drive controller chip. So it looks like this pot may have failed, so I'll investigate that further. If it has failed, I'll find a replacement, get that swapped out, and then in the next video we'll see if we've made any progress.